Hi everyone, this is Mr. Kess here with a helpful video about using statistics in AP research. Now for the record, statistics are not necessary for AP research. You do not need them. Please do not feel like you need them. You do not need any kind of math skills to do a research assignment. However, using some basic statistics can really help you folks take your paper and bring it to another level that you don't have to go to. Okay. Um, Obviously, some of you kids are in like AP stats or you're in calc right now. You don't need to be crazy about it because the people reading your papers haven't taken calculus or stats or anything like that for years. So what I'm going to show you today is some basics of standard deviation and how you can basically word it to make it basically buff up your paper, okay? So here's where we're going to play with this a little bit. So here's my running example for today's video. Here are 8 high school students, and do notice that I'm going to color code the numbers so you see where I'm getting these from. Here are 8 high school students and their IQs. We can calculate an average to determine who is above and below. However, standard deviation allows us to group kids into categories: average, below average, above average. So let's just start by finding an actual average. So I have these 8 students with their 8 IQ points. So we know how to find an average. We just add up all the numbers, divide by 8. And once again, I'm getting 8 because there's 8 kids. So I know a 95.125 is technically the average. Okay, but that's a 1 number starting off point. So we know that Jessica, Riju, Stefan, Swarty are above average, and Anuj, Yanni, Nikki, and Sebastian are all below average. I just look at that number. Okay, is 110 bigger or less than 95? Okay, that's easy for us to determine. But what now we're going to take it to the next step is we're going to compare each person to the average. So, okay, we know that Jessica was above average, but how much was she above the average? And the reason why we're going to take the square root of it is because you can be either side, right? You can be above or below. And that's the reason why we have to square this number, is to get rid of that negative idea that we could be above or below. So if we think about it, let's go with Sebastian, for example, a 91. So we know he has just over a 4-point difference between his score and the average. It would technically be negative 4 point something, okay? But what we do there is we square that. So obviously you folks know this 4 squared is 16. So if it's 4 point something, okay, that's where we're getting 17.02 from. Now, what exactly are we going to do with those numbers now that we have these differences? We're going to add them all up. So we know the squared from the difference of the averages is 930.88. Now, what are we going to do with this number? We're just going to use it again later. So at this point, we're getting a sense of where each person is related to the average. We also know that the sum of how far we are off from the average. We need to recalculate the average using our analyzed numbers. So we're going to basically make a new average. And if you take that orange number from before and divide by 8, because we have 8 students, we get 116.36. Okay, notice once again how we're going to color this and we're going to bring it to light of everything. The last step is to take the square root of it, because once again, before we squared it to get rid of the negative. Now we're going to do the square root so we can basically cancel out the negative. So what this means for us is that our standard deviation is 10.79. So here's the 2 numbers that we really need to look at: average, standard deviation. So what does that mean for us? We have the average of 95.125. Anyone within plus or minus, because remember the squared, 10.79 is considered with average. So if you notice my little table here, I'm going to go back to Sebastian first. Sebastian was really close. So we're just going to say he was close enough to average. And we could do that for the other people. Anuj, Riju, Stefan, their scores were technically close enough that we could basically say these are average kids. Now, for Jessica, for example, Jessica's difference is 14.875. So remember, that's the 110 score for Jessica, subtracting the average, 95.125. Her difference is 14 and change. 14 and change is bigger than 10.79. So what we know is that she's technically above average. And we can do this again for her. So if she was above 21.58, because that's 2 steps here, she would be super above average. But basically, we can do this for the rest of our students. So we know really, out of all the kids, 4 of them are considered average, 2 of them are above average, and 2 of them are below average. And it gives us a little idea more about where does our data fall compared to each other. And you've probably seen this curve right here. And this is the idea that we use. Once again, the plus or minus the mu there is basically the average right here, this 34 point right here. And really what this does is the standard deviation basically allows us to basically say most of the kids are going to fall within this region, which what happened to us? Most of the kids fell within the region of average. That's what's supposed to happen. That's what really kind of an average is all about. And then you have the outliers. You have the 2 kids that were better and 2 kids that were worse. And if we had more data sets than 8 kids, you'll find this kind of trend occurs as we go on. Excuse me. Now that we know how it's done, we can also just do this in Google and Excel and just do one formula. So let's just say I have all these IQ numbers and I type in this one formula, STDEVPA cells. And when I say cells there, it's literally highlight the cells. So in the example, cells C19 to C26, and I got 10.79. Remember, that's the number I got before. So you don't have to do all the fancy calculations. You don't have to know where the calculations come from. Excel will do it for you. And once again, this gives us a better idea if we have a whole bunch of data sets. Are these data sets within region, or are they below expectation or above expectation? When collecting data from an experiment, you want the standard deviation as small as possible. That means your data is consistent. Large standard deviations should be explored. Sometimes it can't be helped. Here are some examples. So here we go. We're going to measure calories in Cheetos. This is an experiment you may have done in chemistry. You take a Cheeto, you set it on fire below some boiling water or below some water. And you can measure, because the Cheeto is on fire, the water is going to get higher temperature. And there's a calculation that you can do in chemistry. But here's 2 different trials. So the left trial, you can see the average is 7.9. And the second grouping of trials, the average is 7.9. So both of these trials would give us the same average. Now, here's where we can take it into research and where your paper can be escalated a little bit. The left data set had a standard deviation of 0.25. The right standard deviation had an answer of 0.49. So basically, what this means is that the left data set was so consistent that most of the data falls within 0.25 plus or minus. Whereas the other example that we have here, the right-hand side, the standard deviation basically falls within 1. So 0.49, 0.49 on each side. So what your method is in the first example is much more consistent compared to the second example. There is a bigger spread, okay, in the second example. So the second example, if you got that answer as a standard deviation, you can say, hey, I needed to redo this experiment because of this reason. Or you can say as your conclusion, I'm a high school student and I can only afford so much equipment. I would want to retest this again in a laboratory setting where we can improve the standard. So you can talk about that as a result of things. Here's another example that's more study-based. Interview questions. Let's imagine you interviewed 30 teenagers about marijuana. You asked 2 questions on a scale of 1 to 5, 5 being always and 1 being never. How likely would you report a friend to their parents for smoking marijuana? How likely would you lie for a friend when asked by their parents if they smoke marijuana? So once again, there's 2 sides to this story. We can get an average. Okay, that's easy for us to calculate. Once again, we know how to do it. We can even do it in Excel. 1.8 for the first question means to me that somewhere between a 1 and a 2, people are answering. So basically, they're never going to report their friends. But for the second question, how likely would you lie for a friend? Yeah, they're more likely than not going to lie for a friend about their marijuana use. But here's the interesting thing, and once again, this is how you can use the numbers to really take your thing to the next level. The standard deviation for answer 1 was 0.41. So once again, 0.41 plus or minus. In this one, you're giving whole number answers. So basically saying 1.8 is really close to 2. Everyone really gave an answer between 1 and 3. More 2s, mostly 1s between 1 and 3. But there was a consistency. Everyone was on the same page with giving a 1, 2, or a 3. Whereas if I see a standard deviation as 0.94 on a 1 to 5 scale, that means that most people fit a 2-point region. So that means some people said 5 and some people said 1, and we're all over the board. So that's an example where you can say, as a researcher, people were pretty consistent with this response for question 1. But for question 2, we had a vast majority of opinions. Even though we have a 3.9 average, most people will lie. There was a huge separation. You were on one extreme and the other extreme. So hopefully this little video about standard deviation helped you folks out a little bit. Once again, you do not have to incorporate standard deviation and average into your research. However, if you want to get a different approach and show people how you understand the data that you collected, this is a great way to do it without stressing over math. So I hope you enjoy this little tutorial. Let me know if you have any questions. Good luck.